So now let us try to understand this. We will be deriving this. Many of you might have already done it yourself, but I will prefer that we go back to this derivation, and that will help in IF. Means when I write IF, it is inertial frame, and ROT rotational frame. For our problem which we are solving, writing equation of motion, this rotating frame is the body fixed axis, which is also rotating with the body, with body fixed. Inertial frame means it is earth fixed inertial frame. Okay? So the another definition is that inertial frame, I should try to understand the unit vectors I, J, and K are not changing. Then magnitude is 1, direction is not changing, fixed. But for rotating frame, this I, J, K, as the body rotates, they also rotate. So the direction is changing, although magnitude is not changing, it's a unit. But direction is changing, so this vector is changing. Okay? So that is how it doesn't remain inertial frame of reference. Okay? So how that is to be developed, and let us see. Let me define a vector A. Right? I can define this vector both in inertial frame and rotating frame, because both are having axis system. Okay? So for A in inertial frame, I write as AX IE plus AY JE plus AZ KE. Okay? So let's dot dot dot. This is defined in inertial frame. I can define this vector is same. I define this in rotating frame. So in rotating frame, the scalar component of A will be different now. So this is, I say AX prime I cap E, I put a prime. The moment I put a prime means this is referred to rotating frame, plus A Y prime J this plus A Z prime K prime prime. Please understand, I should not slip this prime. Once I say prime means this is defined in rotating frame, RF, rotating frame. Clear? Okay. Now let's take this A. Let's talk about inertial frame. I am doing derivative in inertial frame. So dA by dt will be equal, in general what it will be if I write mechanically the vector definition. So this will be dAx by dt into IE plus AX plus dIE by dt. Similarly, second term will be dAy by dt into j cap earth frame. So I must write E earth plus AY into d j earth by dt plus similarly AZ d by dt of K plus dAZ by dt into K. Let me repeat, dx by dt, I vector ax, this is fine, dy by dt, j ay d, this is fine, az dk by dt plus daz by dt. I have already written it first. Now, what is important? What is the value of di by dt, dje by dt, and dk prime e by dt? What is the value of that? Because we are now computing this in inertial frame. Do not forget, this is in inertial frame. So what we know in inertial frame, it is earth fixed, and the unit vectors along these directions, x, y, z directions, are not changing in direction or in magnitude. Magnitude is one unit vector, and it is a fixed, it is not rotating. We have assumed that earth as a non-rotating platform for our purpose. So these derivatives, since they are not changing, this is equal to 0. in inertial frame. Correct? Any doubt? So this is 0. So what will happen? So dA by dt will become what? Now dA by dt, let me write here somewhere so that I can use it appropriately. So dA by dt in inertial frame is as simple as dx by dt IE plus dAy by dt JE plus dAz by dt KE. As simple as that. This is derivative of vector in inertial frame. It is nothing great. We have been all doing in class 9, 10th. We are talking every problem was solved in inertial frame. So what is the, if I say A is V, if I say A is vector is V, then what does it mean? It means dV by dt is dV x component into IE plus dVy by dt JE plus dVz by dt in KE, where the V has a component, V has component Vx IE plus Vy JE plus Vz KE. So what are Vx, Vi, Vz? They are the component of V in the inertial frame. X component is Vx, Y is Vy, and Z component is Vz. So what will be the acceleration? That will be the, because it's the inertial frame, so along x, acceleration will be dVx by dt. Along y, it will be dVy by dt. Along z, it will be dVz by dt. Okay? Correct? So this is very, very clear now. And inertial frame, no problem, that we have been doing. Now let us see a derivative in rotating frame, because we want to work in rotating frame. Okay? Let me start from the beginning so that there is no confusion. Before I do that, please understand, A is defined here in inertial frame. Same A vector, vector is same, has been defined in rotating frame. The vector doesn't change. Okay? Whatever frame you put, totally the vector is same. Okay? So now, I am to work in rotating frame. Rotating frame for our case is the body frame, is the example of rotating frame, because as the body moves, the rotating frame, which is a body fixed frame, it will also rotate. So let us see how do I differentiate dA by dt using body frame. So body frame A is this, so d by dt A bar will be equal to, see here, it will be d ax bar, prime by dt into I prime. What is I prime? I prime is the unit vector in the body frame. Oh, this should not be E. Okay, please correct it. Right? This is wrong because this is not earth frame. Right? This is a body frame. I repeat here. Please see, I have written A as like this. Initially E was there, so I am erasing that because this is written in the rotating frame or the body frame. Body frame. Sorry for this confusion, don't worry. It's better sometimes you write something wrong and that stresses your mind and you learn better. So do a correction. When I am defining A vector in body frame, their scalar components and their unit vectors are different now. Okay? The unit vector in body frame is I prime, J prime and K prime. The components are Ax prime, Ay prime and Az prime. Correct? So now I am differentiating, so I get dx prime by dt I prime plus Ax prime d I prime by dt. Immediately you know that now di prime by dt will not be 0 because body frame, as the body rotates, frame rotates, so direction of unit vector rotates. So di prime by dt cannot be 0 because vector is a different vector if it has a different direction, even if magnitude is same. Right? So what is the next step? Next will be d_ay prime by dt into j prime plus ay prime into d j prime by dt. Similarly, the third term will be d az prime by dt into k prime plus a z prime into d k prime by dt. All the terms are here. This I, E, J, E, K, E were the unit vector in the earth fixed reference. I prime, J prime, K prime are the unit vector in the body frame reference. Initially, I wrote here I, E, J, E and K, which is wrong, absolutely. Okay, because unit vectors are different, right? Okay, now see, you know that now I cannot write di prime by dt or dj prime by dt or dk prime by dt is 0, because you know vector is changing, the direction is changing. Question is, how do I find out this vector? Okay, very simple. Let's say this is a circular motion, this is a r vector, and this is rotating with omega. Then you know that dr by dt equal to omega cross r. Very simple, isn't it? Vector rotating like this, so dr by dt is omega cross r. Omega is a vector. What is the omega? Omega is the angular velocity of the rotating vector. Okay. So now for r, if I write I prime, okay, that's the unit vector in the body frame of reference, then what will happen? This will give me simply di prime by dt equal to omega cross I prime. So simple. Now if I put r bar equal to j prime, this implies dj prime by dt equal to omega cross j prime. Similarly, if I put r equal to k prime, this gives me d k prime by dt equal to omega cross k prime. Fantastic. This is so elegant, so simple way of find out what is the di prime by dt, dj prime by dt and dk prime by dt. Okay. Now what is the solution? Solution is you have to put it here. So dA by dt will be equal to dx prime by dt. So I write it dAx prime by dt into I prime. I write d ay prime. I'm just doing some rearrangement. So j prime. Similarly, d az prime by dt k prime. Then what is left? So this I have taken care, this I have taken care, this I have taken care. What is left? This is ax prime di prime by dt, and di prime by dt is omega cross I. So I write this is omega cross I prime. Similarly, so this is taken care. Similarly for this, this is ay prime into dj prime by dt is what? That is omega cross j. So this is omega cross j prime. Similarly for az, I will get az prime to omega cross k prime. Now see this term. This term I can easily write, or let me write a complete term so that you understand better. Let me erase this part also. Right? As long as we understand what we are doing. So what we are getting, dA by dt equal to dAx prime by dt into I prime plus dAy prime by dt into j prime plus d az prime by dt into k prime plus, for this I can write as omega cross ax prime I prime plus ay j prime plus az k prime. Right? Just simply I take the common. So this tells me what? What is dx prime by dt, dy prime by dt, daz prime by dt? That is the beauty. What is it? It says, don't worry about rotation. Rotation will be taken care of by this gentleman. You see, what is your component of the vector in x direction? Local x direction, body x direction. Find that derivative. Similarly, body y, find that derivative. So you are operating in the body frame now. Okay, because x prime, ay prime, az prime were respect to the body axis, right? So this is, I write dA by dt in body frame, and very simply, you know, this is omega cross A. So this is equal to your dA by dt. You may have a question, when I take omega common, so in this case, when I wrote this, you see ax prime, ay prime, az prime, okay? So what we have understood is very simple now, that dA by dt is equal to, in inertial frame, is equivalently, I can work in body frame. In body frame, I have to add omega cross A. So in our problem, we have vector differentiation, which demanded it should be done in inertial frame. What was the differentiation? One was d by dt of v m dv by dt. That was the force external, right? This should be in inertial frame. Because here, of course, here we assume m dot is 0. Similarly, we know for m, it should be d by dt of h, angular momentum, again in inertial frame. But this telling, either you do in inertial frame or equivalently you work in the body frame and add this. Okay? So that is the way we work in body frame, and at the same time we do not violate the condition for Newton's law that it should be in respect to inertial frame. Right? So now with this understanding, we will complete first part of derivation of equation of motion. Okay? So now we will be using this to complete the derivation of equation of motion. What we wanted was F equal to m dvc by dt in inertial frame, and now we know that that is equivalent saying dmvc by dt in body frame or rotating frame and comma omega cross vc. So this is equivalent to working in the body frame, right? Inertial frame, we are now expert in this. What is vc? Let's understand. U I in body frame plus v j in body frame, k and w k in body frame. We are working in body frame, please understand this, right? And what is omega? Before I come to omega, what is the meaning of UVW? It is the x component of the Vc, which is measured with respect to inertial frame, but the x component is resolved into local body direction, body fixed axis I direction. Similarly for V and W. And now we say omega I write as P I plus Q J plus R K. What are PQR? PQ are the component of omega, and omega was measured with respect to which frame? Inertial frame. But PQ are the component of that omega resolve into local x, y, z body fixed axis coordinates or axis system, right? So now if I do this, what I get? I get fx I plus fy j plus fz k will be equal to this m d by dt of Vc is ui plus Vj plus Wk, this plus omega is Pi plus Qj plus Rk omega cross Vc. Vc is again ui plus Vj plus Wk. It's very simple now. You find the right hand side, you can easily write from here by equating x component and y component, fx as m u dot plus q w minus rv, fy as m v dot plus ur minus wp, okay, and fz as m w dot minus uq plus vp. This is the beauty. You are now allowed to work in the body frame. See from here, if you are working in inertial frame, suppose you are working inertial frame, then what will be the fx? Fx will be simply m u dot. These two terms will not come if it's inertial frame. These terms are coming because of this omega cross A, right? Because of you are trying to correct for not being operating in inertial frame by omega cross A, that vector, or omega cross whatever v or angular momentum, soon you will see. I repeat here, what are UVW? UVW are the air relative speed resolved into local body fixed axis coordinate. What is V? Vc, what is Vc is the velocity of the vector with respect to inertial frame. Okay, correct. That can be resolved into this, written in the local body coordinate system, like we wrote A vector both in, what we did? We wrote A in Ax IE plus AY JE plus like that. Similarly also we wrote A as Ax prime I plus AY prime J prime plus AZ prime K prime. So this is what we are doing. We are writing that vector which was with respect to inertial frame, we are now writing with respect to the local frame. Now you could see if I put a sensor in the aircraft, I can easily get UVW because now it's a body relative. Okay? And aerodynamic forces will be easily computable because now UVW we are getting air relative, right? Air relative speed. And then next question will come, what is Fx, what is Fy, what is Fz? We will discuss about that. Before I discuss about Fx, Fy, Fz, let us complete the moment part. Okay? There is another equation is waiting for us to be handled. Let us handle that. So let us now complete the moment equation, and we will be following the same help, which is dA by dt inertial frame equal to dA by dt rotating frame or body frame for our case plus omega cross A. So we know we need to calculate m as d by dt of h, angular momentum vector. So I will use this. So dH by dt in inertial frame will be equal to, I will find dH by dt, dH by dt in body frame plus omega cross h. And you know, h vector has to be expressed in body frame. We know the component of HH, So I will simply write this as d by dt of, let me write, p ix minus q ixy minus r yz, and this is now I, that is in the body frame. This is first term, and the second term will be d by dt of, what is this term? This is minus p ixy plus q iy minus r iyz j prime. This is the unit vector in body along body j direction. So the third term will be d by dt minus p ixz minus q iyz plus r iz k prime. This should be right. R I y z. So many expressions you have to write, so be careful. That's why I repeat. Once in lifetime you should develop this. Do this by your hand, and life will be very comfortable. You cannot avoid this also if you really want to be a good flight dynamics man. Generally, notation wise, we would double script. For ix we write ixs, for iy we write iyy, for iz we write izz, right? So third is minus p ixz minus q iyz plus r izz. Fantastic. This is the first term. Then omega cross h. So plus omega we know pi plus qj plus rk omega, and h also we know h as these expressions, right? So h. For the expression of h we have used here, you all know. So if we expand it, simply derivative and take derivative and expand it, do not forget this term. It's important. H you have to write h as hx I plus hy j plus hz k, and this is nothing but hx, nothing but hy, this is hz, right? You have to put it here and do this operation, and then you will get 6 equations. Let's see what are those equations. So once you do this part, already you have seen m u dot minus vr plus wq, this is equal to fx, and you know m v dot plus ur, m v dot plus ur minus wp will be equal to fy, then m w dot minus uq plus vp is equal to fz, and if you do this operation, you will get equation like this: ixx p dot minus ixz r dot. So we have seen this fx, fy, fz came from one set of equation, and when you do this whole operation, you will get equation like this: ixx p dot, let me write this, ixz r dot minus ixz pq plus izz minus iyy rq, and that will be equal to the component of moment, because remember, this is the rate of change of angular momentum, and that is equal to the moment, okay? That is causing the rate of change of angular momentum. And this m has 3 component Li plus Mj plus Nk. What is L? L is about x-axis, that is rolling moment. This is rolling moment. We'll go detail about it, but at present you know this. M is, you understand, pitching moment. Pitching moment about y-axis, that is by j bar here, and N is yawing moment, okay, which is about z-axis. So now if I take L, M, N and compare their components, scalar components, we get this sort of an equation. This is L, which is rolling moment, and then you will get I, Y, Y, Q dot. Let me write, because every possibility of writing it wrong, I, Z, Z, P, R plus I, X, Z, P square minus R square, okay, equal to M, which is the pitching moment, and the third one is I, Z, Z, R dot minus I, X, Z, P dot plus I, Y, Y minus I, X, X, P, Q plus I, X, Z, Q, R equal to yawing moment. So you have got 1, 2, 3, 4, 5, 6 set of equations, and you know these are 3 for translatory motion, these 3 are the angular motion. You can see P is rolling about x-axis, Q is pitching about y-axis, and R is yaw rate about z-axis. So we have got explicit equation. We need to know what are these Fx, Fy, Fz, what are these L, M, N, how do they vary when an aircraft is disturbed, either in terms of orientation or in terms of external condition. And when you both understand this, we will be able to do justice to our stability analysis. But before we go to that, in the next class what I will do, I will again start from here, explain the each term, physical meaning of term, and then now you know that for computing Fx, Fy, Fz or moments, you need to know the angle of attack, the side slip angle. So it is the angle between the velocity vector and the chord line or axis of the airplane. So it is extremely important to know, to define some equation where I can see how do I model the axis orientation of the airplane, because the axis is fixed to the body. So as the body moves, axis also moves. How do I define the orientation? So that orientation again we have to do with respect to inertial frame. Okay? And there is a catch in that, and we need to understand very subtleties of that, because it's a rotation. Remember, rotation is not a vector, but small rate of change of rotation is a vector, can be treated as a vector. So there will be some complexities. So our role will be to go slowly and clarify those doubts, so that when you are going to implement this, you are master of these equations, right? Thank you very much, friend.